All right, get out your notes, please, and title them mid-segment. Little did you know that there are not 4 types of special segments in a triangle. There are 5, and mid-segment is our 5th one. So title your notes, oh geez, I know. Title your notes mid-segment, and then please draw this picture. The 5th wheel instead of the 4th wheel. Yeah, he gets his own day. I don't know, he's pretty special. It's just we didn't want to give you 5 all in one day, and this one's just kind of different. He has his own theorems, and so I don't know why I'm calling it a he, but they get their own day. I printed out the homework yesterday and looked at it in fear. Okay, so title it mid-segment and draw that figure. So let's see if we can come up with our own definition for what a mid-segment is based off of this picture. I'll go ahead and give it away. ED is the mid-segment. He's the star of the show today. So what is ED's job? Remember, all those special segments had a job to do. What is ED's job? What is E? What is that point? It's a midpoint. Very good. So E is a midpoint. What is D? Another midpoint, right? So it's looking like this new special segment's job is to connect a blank to a blank. Yeah, you said it. Connect a midpoint to another midpoint. Yep. How many mid-segments does a triangle have? It has 3. Because if I draw all 3 midpoints, pretend this is the 3rd midpoint, I don't even know if it really is, just eyeballing it, then I could connect midpoint to midpoint, midpoint to midpoint, and then of course the one that's already drawn. So a triangle will have 3 mid-segments, just like it has 3 of all the other special segments. So write down the definition of mid-segment. You don't need to draw a new picture. You already have that picture in your notes. By definition, a mid-segment is the segment connecting the midpoints of 2 sides of a triangle. So now we know the definition. Now let's figure out what conclusions can be drawn once we have our mid-segment. Like, what is so special about a mid-segment? Why do we care about mid-segments? Okay, so I purposely drew a triangle that was not isosceles, that was not equilateral. In fact, I drew one that was obtuse and scalene on purpose to show you that these theorems are going to work in any triangle that you're given. So the first theorem has to do with the length of the mid-segment. How long is this mid-segment? So we're going to do this one first. How do you think the length of DE compares to the length of BC? So every time you draw a mid-segment, the length of the mid-segment is is what? 1/2 of the 3rd side. So DE, and don't write this down yet, because we're going to write it a little bit differently, is 1/2 the length of BC. BC is double DE. And I don't call it the base, because in a scalene triangle there is no base, but I call it the 3rd side, the side that wasn't used to create DE. Okay, what do you think is true about the slope of DE compared to the slope of BC? Yeah, when 2 segments have the same slope, what are they? 9. So that's another theorem. We're going to write it down on the next slide, so you don't need to write it down yet. Segment DE is parallel to segment BC. That's not true just for that one right there. It's true for all of them. So if I look at this segment right here, how many of those segments does it take to make AC? Oh, it takes 2 of them. And what's the slope? Look, all of these have the same slope. Can you tell? They're all sloping at the same direction. So that segment is parallel to its 3rd side. And the other one would be parallel to its 3rd side as well. Let's summarize those with the triangle mid-segment theorem. We just keep adding more theorems to the list. We are going to be full of theorems by the time this year is over. Write it down, please. Triangle mid-segment theorem. You don't need to redraw your picture, but you do need to write the theorem And then here's the theorem summarized with symbols. Okay, we have one more quick theorem. So we want to know, you already alluded to this, when we do draw all three mid-segments of a triangle, something really cool happens. So in this one, it's a nice equilateral triangle. You're probably not impressed by this or surprised by this, but what are you finding is true about these four triangles that were created? Legend of Zelda. They're all four congruent. So when I draw all three mid-segments of a triangle, I get four congruent triangles. Like I said, not very impressive in an equilateral triangle. So let me show you that it also works in this crazy scalene obtuse triangle. I drew mid-segment, 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 connected them, and it created 1, 2, 3. Oh no, this is the wrong triangle. It really does. Oops. Let me show you. It went here. Okay, that's where it came from. And now, pretty cool. I think it's cool. So no matter what kind of triangle you were given, if you draw all three mid-segments, it will divide the triangle into 4 congruent triangles. Someone was asking, not right triangles. Oh, probably hate them. I can look at that. Someone was asking, how does the area compare? So one of those triangles, its area would be 1/4 of the area of the total triangle. Write down that conjecture, and then we'll try 2 examples. Let's go through these. You're not even allowed to write this in your notes because it's that easy. If AC is 20, then DE is, we're back in kindergarten. What? 10. 10. Yes, yes it is. If BE is 6, then BC is 12. So if E really is a midpoint, then we've got 6 on either side for a total of 12. If DE is x plus 6 and AC is 3x plus 4, then x is, so I would double my mid-segment to equal my third side, right? Double your mid-segment to equal the third side. You could cut that third side in half, but I don't like decimals, and when you cut 3 in half, you get a decimal. Last problem of the day. Okay. UA is 24, TN is 6, and UT is 8. Find the perimeter of UPA. Let's start with up. How long is up? What's the length? Good. So if T really is a midpoint, then this is 8, this is 8 for a total of 16. What about the length of PA? Good. A mid-segment is half of the third side. So that third side would be 12. So the perimeter is 52? Yep. Okay, I have a couple more questions. What about the perimeter of PEN? Okay, so how long is PE? You find the side that is parallel to, and it's half of that side. So it's 12. How long is PN? You find the side that is parallel to. You might want to color code some things. And it's, don't trust the phantom. All right, what about the perimeter of TEN? It is 26. What do you notice about the 2 perimeters? Yay. So the perimeter of that triangle, triangle TEN, created by the mid-segments, is half, of course, of the perimeter of UPA, which was the original triangle. Yay. Okay,